Okay, so today let's start writing some programs to just utilize our API with the LLM. Just to remind ourselves, we do have this convenient start Quen alias on our system here to just quickly start up the LLM server. It's just this entire command that I like invoking. So, oops. So I can just do source bash rc if you just added it, and just do start Quen, and then we can quickly start the LLM server this way. And again, if we ever want to use the web UI, it's available for us here. But I do hope that one day we'll actually start creating our own web UI so that we won't have to stick with this all the time. You can also go, again, we created an install of Open Web UI too, and we could always use that. But again, I would like to get to a point where we can use our own thing. So here we have it accessible at 8080. So we're running like many things here. Okay, enough of that. We went through an exercise in using chat completions for accessing our LLM by basically inferencing. So let's actually start creating some code. Let's write some code to invoke our API programmatically instead of using Bruno. So what I'm going to do here is I am going to actually configure my VS Code real quick. I'll be right back. Okay, VS Code's a little bit more set up to what I like. I just basically installed a few extensions here. Of course, we'll need the Python extension. I also installed the Capuchin, and the Vim extension. So things should be nicer. So I'm going to open up the average dev repo. It's been a while since we've been here. I'm going to create a new folder, maybe called AI, for our AI studies. And let's just open that folder here. Let's trust everything up here. We're safe. And then let's open up the Git repository up at the parent folder. So that's okay. Let's open up average dev, and we should be good, I think. Okay, so let's create our first project. We'll just call this LLM API or LLM chat completions test. Okay, LLM chat completions test. And it's going to be a Python script. So what we can do is we can open we can create a new file and call it main.py. So that's what we're going to be running. And just for convenience, we'll have a terminal down here. First thing I like to do whenever I create a new project, especially in Python, is just create a corresponding virtual environment with it. And again, I think we have Python 3.12.3 here. Oh, let me make that bigger. Was it terminal font size? Terminal font. I think we can make this 18. There we go. That should look better. Okay, yeah, that looks better. Okay. This just means I had to write tighter code because I only have this much space to work with. Let's see how good I am in terms of my efficiency on space. Okay, so what I like to do is I like to create a virtual environment within the directory of where I'm working at. So LLM chat completions test would be in here. So I can just do Python 3-m venv and just create a virtual environment in the folder. It's a hidden folder .venv. And then after that, after I've created this thing, I can just activate it with source.venv bin activate. Okay. Next thing I like to do is, if you notice this, we have now 1K files awaiting for commit. That's not good. We need a git ignore too. So we can do npx git ignore venv. So sorry, not venv, Python. So that will allow us to create a git ignore pre-filled with all things Python essentially here. And we'll just add the .venv folder at the end so that we can ignore the virtual environment folder. And when we do that, I think if we were to refresh here, maybe things will go away. Why not? Oh yeah, it did. For some reason, this is not reflecting, but yeah, we only have 2 changes now. So that's good. The next thing, if you're on VS Code, is that although you're on a virtual environment here, it's recognized. Sometimes it's not recognized up here. Like Visual Studio Code's Python plugin needs to kind of make that connection saying, hey, I'm using this specific Python interpreter, so find all the libraries up in this folder. So what I like to do is I just want to link up that virtual environment. And the easiest way to do that is to bring up the command palette and do create environment, Python create environment here. So this specific one, if you were to select that, you can just select venv, and then you can, I think, use an existing one. So if I were to just select enter interpreter path, I could find one, well, I have to do absolute path. It'll be code average dev projects AI LLM chat completions test .venv bin Python, and it says creating environment, and it says upgrading pip, yada yada yada. So we're correctly linked now. So the following environment is selected, so it has to be the absolute path apparently. Okay, so next we're going to install a library called requests. It's a popular Python library to make requests, HTTP requests. So if you really want a reference, you can just do Python requests, and then I think it's going to be HTTP for humans, this document right here. And I'm just going to favorite that because I think we're going to come back here a lot. But I know how to use it relatively well at this point, so it doesn't really matter for today. So it's as easy as pip install requests. Since we're in our virtual environment, pip install will work directly, and it's going to install the package on our virtual environment. So, okay, that was fast. And then all we need to do here, oh, why is it created? Why did it create it up here? Bizarre. What? Weird. Okay. Anyway. Okay, I don't know. Let's see, import requests. Does that work? No, it didn't work. So we used the wrong virtual environment. So let's do this. Use existing. What is the existing one? I want to see. What did you use? No! Okay, you know what? Let's delete that. Okay. Okay, so let's see. Let's make it recognize our requests by selecting the proper virtual environment. Let's try this one more time. I think it's because my absolute path was not correct. So, enter interpreter path. Let's do it. Home, average dev, code, average dev, projects, AI, LLM, chat completions, tests, .env bin Python. Okay, well, it did it again. Why? Maybe we should have just done that to begin with. You know what? Let's do that. Let's deactivate. Let's just delete this thing. Let's just delete it. Okay? Let's just delete it. And then let's activate the one up on top. So source. Told you. I'm just an average dev. Okay, there we go. Now we just do pip install requests. And this should work. Like if I were to install requests up in this virtual environment, I think this will work. So all I have to do is just type that again, and it recognizes it, right? So in this case, the new error is not accessed, right? So maybe let's see, restart. Restart language server. Restart. Whatever. Okay. And there we go. No more squigglies. Okay, cool. It recognized everything. Weird. Very weird. All right. Okay, so we have our LLM server. So that's going to be base URL. And it's going to be on HTTP, localhost 8888, and v1. That's like our base URL for API for how we did here, right? So we're just going to do chat completions when we really make the request. So then we're going to specify a model. It doesn't matter. We'll just call llama.cpp. It's really more like the Quen 2.5 7b instruct thing, but I don't think it doesn't matter when you're running llama CPP. So we're going to make a simple request. We're just going to provide some payload and then make that post request to the chat completions and resource. So we did payload here. We'll just specify a Python dictionary that's going to be kind of like our JSON, right? So that'll be our our request body. So we're going to provide the model. We're going to provide the messages, and that's again just an array. Oops, I don't know why that. Okay, so that's going to be an array, and then we're going to say stream. It's going to be false. So we don't want stream. Now in this messages, we're going to have another dictionary that's going to specify a role. It's going to be user with the content, hello there, as a message. Okay, so we have the payload, we have the base URL. Now we just need to make that an API call. So API call is going to be chat response. It's going to assign the response for the API call. So we're going to do request.post. We're going to specify the full URL, so it's going to be base URL, which is going to be the HTTP localhost 8888/v1. We're going to /chat/completions, and then we're going to provide the JSON payload. And this is how you would pass JSON to a server with the request library. At this point, we know that what is returned back should be a JSON because that's what happened here. Originally. So the chat response is the entire HTTP response. So we just want to extract the JSON body from that. So we can say response JSON is going to be chat response.json. So that's a method from the HTTP response. And let's just print the response JSON. Just see what do we get raw. Okay. Now let's test our code. So we have all this here is just a basic API call to our LLM. Okay, so Python main.py. Since we're already on a virtual environment, it should find all our dependencies. So that was quick, right? So because we're using the GPU. So we got this JSON, or not really JSON, but more like I guess like a dictionary. We had to convert it to a JSON, I think. So yeah, so this is our dictionary here, and I think we could format it correctly if we import the JSON library. So from Python, we can do import JSON, and since this is an object here, we can say response formatted JSON is going to be JSON dot dumps. So dump string. It's going to be the response JSON object. And we can specify an indent to be 2. So we're going to be indenting by 2 spaces. So response formatted JSON is going to be printed out. And we can run the script again. So, okay, good. It's cleaner. So let's take a look at what we have here. So it's the same thing, right? So it's going to be the first element of the choices key here. So it's an array. We're just going to extract out the message object and dig into content. This is from assistant. Okay, so it might be worth just taking out this thing in general. right? So yeah, we can just do that. And then again, all the stats are here. So that's cool. Yeah. But we're just interested in the response and things like that. So I'm gonna comment this one since this is kind of like a string already at this point. So it doesn't really make sense. This is just for debug. So we can just say for debugging. Okay. And then, so we want the choices. So how we do that is we want to check to see if there's a choices inside response JSON. So if choices, right, the string, the key choices isn't, right, in response JSON, then we just want to raise, I don't know, key error. Is there a key error? Yeah, key error with no, what is it? What should we call it? No choices key in the response dictionary, or in the JSON dictionary, the response JSON dictionary. There we go. Yeah, and then yeah, we'll just kill the program. Okay, so then once we get past here, we know that we have choices. So we also want to check to see if there is something in there. So if len of response JSON at choices, right? If there is something, then do stuff, right? Otherwise, we can just print something happened with the LLM. Okay. We could also raise an exception too. So, but yeah. Would it be worth printing something here? Maybe later. Okay, so now here is when we actually have stuff inside, right? So we'll just go choice is going to be response JSON choices. We should say choices. And we're going to select the first element. So we'll call it assistant response is going to be choices at 0. And then we can say assistant message is going to be choice assistant response. And we're going to dig into the message key. Okay. Then we can print out assistant message here. So that's our message object. Okay. There we go. So we got that nicely done. Okay. Let's actually just print out the content. Oops. And we have it. Okay, cool. We're still not at the stage where we kind of want each token to appear like one by one, right? Like right now we're basically getting the response as a whole and then printing out the content. But that's kind of like not fun, because if, let's say, for example, we have a prompt to ask the LLM, what's can you tell me the history of CUDA? So can you tell me the history of CUDA? I think it's going to come up with some lengthy response, and it's going to take forever at this rate. So if we invoke that again, it's going to take some time for us to get a response back. So already I can tell it's more than 10 seconds. It's probably already hitting 15, 20, you know. So let's just wait a little bit. And you're going to just see a response just like come out. And it's most likely going to fill up this entire terminal too. So and I'm purposely like, you know, waiting just to show the pain. So there's like a psychological thing here. Like if we were to, like, let's say, stream the responses token for token, it takes the same amount of time, but you kind of feel better because you see something happening. So notice how I just like kind of checked everything out to us in one go. I'm not gonna really read this, but I'm gonna trust that it's kind of right. I mean it is CUDA 12 already. So yeah, so let's ask the same question on Open Web UI and see the effect that like, let's just observe what happens, and then we're going to try and emulate that. So if I copy that and then go to Open Web UI, and I'll just send the same thing. Oops, how do I get rid of this? I think it's trying to, there we go. So notice how it's like streaming the tokens. This is what we want, right? We want our program to do the same thing. So the next step for this is going to be pretty important because this is going to be the pattern that we'll be using for the duration of all like our LLM applications that require like visual feedback. So yeah, let's move on to that after we finish this. Should be the same response, I think. Not really, I guess. They didn't mention CUDA 12. But anyway, yeah, next steps. Okay, so now the next step is that we want to emulate this like streaming effect. So when we make our request, it's really not as simple as setting this to true, because what ends up happening is that we're gonna get something not ideal. So oops. So let's say true, and let's just say if we were to just invoke this script again, you're going to notice that I think it just doesn't even like register that you want to stream. It just like kind of straight up tries to process the entire payload again. And I think what will end up happening is that you'll receive a different type of response, and yeah, it's going to be like garbage. So what we want to do is we want to write some code that will actually stream back the responses. Okay, and it crashed because it's not real JSON that comes back. It's spoiler alert, like when you stream the responses back like this, it's going to be in like raw data, and you have to interpret that data as like raw text. Then you take that raw text, you kind of shape it back into something that looks like JSON, and then you convert it back to from JSON string to a Python dictionary, and then you do your stuff with it. A lot going on, but basically it's not as simple as setting this stream to be true. What you also need to do is you need to make a post request with streaming on to stream the responses back through some like networking thing. And so the pattern is going to be slightly different here. So I'm going to just comment this all out so that we have something to compare against later. But what it really is in Python, it's going to be with request.post. We're going to make the same request to the same place again. So base URL, chat completions. Oops. And then we're going to pass the same payload. But this time, there's another option in request.post called stream. I think it's called stream. Requests. There we go. Now I should find it. Stream. Yeah, there we go. If we set stream as true, it's going to give us back an iterator. So we can say this is as chat response iterator. Okay. Well, yeah, it's an iterator. Yeah. So what we want to do is now in a for loop, we're going to process every single chunk. But what do those chunks look like? So let's print that out. So for chunk, okay, in chat response dot chat response iterator dot iter content. Okay, iter content. You can specify chunk size to be none. Okay. We're going to just check if there's a chunk available. We can simply decode this chunk as a string and print it out. So raw string is going to be chunk.decode UTF-8, and we're going to print the raw string. Okay. And now let's see what happens here. Okay, so I'm going to comment all of this out too. So those control slash, and let's see what we get back. So running this again, see we get a bunch of strings back, and let's just let it do its thing for a while, and then we'll check back what the results look like. Okay, it's done. So let's take a look at what we printed out in each stream we got back from the server. So first things first, you'll notice that when we're done streaming data, the last piece of data that's always streamed back to the client will be the string data : done. And that just tells us that there's no more data to come back at us. So we should stop trying to process things. But the second to the last one is going to be, it looks like it's text with prefix data here, and what would look like as JSON. Notice that there's a finish reason here called stop. It means for us that the LLM has stopped processing or stopped generating tokens at this point. So that's also another signal for us to stop expecting things from the system. But everything else is pretty straightforward because it's the same thing over and over and over again. If we look closely, again, it starts out with data followed by a string that looks like JSON, which isn't exactly JSON, it's just raw string. We'll need to parse that out. But basically, again, choices is an array, and the first element here is going to have content, but it's not going to be called message. It's going to be called delta. So delta will contain content, and content is basically the token that was generated. So let's just kind of carefully look back from the bottom up to see what we get, because this one's empty, but this one's a period, this one's researchers, this one's and developers. So putting that together, that's basically the developers and researchers with a period. So we're streaming this piece of text token for token, right? So what comes back is just individual tokens within this entire payload here. Now let's try to recreate that streaming effect, right? So let's take this raw string first, and let's actually check to see if it starts with this data thing, right? So if raw string that starts with data, okay, what we want to do is we want to just substring or at least chop away that data away, right? So in this case, it's about 1, 2, 3, 4, 5, 6 characters. So we have 6 characters. So we can just say raw string is going to be raw string slice starting from 6 and onwards. And that's also trim too. I think it's called trim. We'll see. So let's test that real quick. Even though there's a lot of data, we can just kill the program when we're done. There's no raw string, has no attribute trim. It's stripped. Okay, stripped. It's called strip. Okay, so let's try that again, and it looks much cleaner now. So I killed the program, but you see that each stream is giving us back what looks like JSON. Now raw string can either look like this, or it could look like this done thing here. Okay, so we're going to have to check to see if raw string is done. We want to break from our loop because we're done with our program. So these are all the pre-processing steps here. We just want to stop doing things once we're done, okay? But if we're not there yet, we can just try to parse the data that we get back here, this individual pieces of data, as JSON, okay? Now, it isn't always going to be JSON, maybe not. We don't know. It's raw string. So we should wrap this with exception handling. So we can do try. Okay, we're going to try to parse the JSON. So parsed JSON. Okay, we're going to do JSON.loads. So that's the opposite of dumps. So we're going to load a string to be JSON. So that's going to be the raw string at that point, because we know that it's not done anymore. If it was this string here, we would have broken from the loop already. We would have went away from the loop and continue execution outside the loop. So now we have parsed JSON, okay? And let's again just print out that parsed JSON just to see, if we're okay. Otherwise, we can catch an exception. So we're going to accept error, just some sort of error. Is there just like a generic error that we can, is it exception? I guess it's exception. Exception. We can just print alert couldn't parse JSON. And then we can also print out that raw string just for us to know. And at this point, we can just exit right away. So we can catch that. So, okay, so let's just print that out. Let's print out the parse JSON. We can get rid of this and see where we're at. Okay, so far everything looks good. We're parsing these JSON objects. And we can tell they're objects now because they are single quoted strings, which is very Pythonic. Okay, so at this point, right here in this try block, we have stuff, right? So we can do the same thing again. So remember this check here, if choice is not in yada, yada, yada. We'll basically bring that up here. So we want to take out that first choices, go into that first element, get into delta, grab that content, right? So if choices not in parsed JSON, we'll say print couldn't find choices, or we'll just raise an exception. So we can say raise value or key error. Okay, raise key error, couldn't find choices. Okay. Otherwise, we'll just keep going. So we'll say assistant response is going to be choices 0. Okay. Oops. Choices is going to be parse JSON choices. There we go. And then we're going to say delta content. We can just assume, okay, assistant response at where we at delta. Okay, delta. Let's just say delta. Okay. Now let's do this. If delta not in assistant response, raise key error, couldn't find delta. Okay, now we can dig in. And finally, if content not in delta, we could say raise key error, couldn't find content. And then we'll say content is going to be delta content. And finally, let's print it out. Print content. And print always inserts a new line character, so we can say end could be nothing. We'll just be like blank, right? Non-new line. By default, it's a new line. So then if we do this, we should start seeing every token stream in our terminal. So let's try that. And it should start doing that shortly. There we go. So yeah, so it is kind of slow still, but we're getting there. Okay. So yeah, so let's further refactor, refine, whatever we want to call this. Okay. Okay. So before I continue, I realized I missed another argument here. So the reason why this thing was like generating line for line is because the print was not flushing fast enough on time, so it didn't create that cool effect that we really wanted. So the trick here is just to add a flush true to make sure we flush every single print statement out to standard out. So if we execute the script again, it'll be more like this. So there we go. We basically have emulated open web UI now, right? Okay. Yeah, so next step, I said, it's clean up, and so we could probably turn this into some reusable function, which I think it might be helpful to do that because this is something that we're going to kind of take over, like take on and use in future projects. So I'm just gonna admire this for a bit and well, okay, there we go. What's going on here? Oh, because there was no delta object, so we just printed this straight up. Okay, alert couldn't parse JSON. Okay, that's fine. What can we do? Let's fix this error. Let's go up. Where did we say that alert was from? If choices, try. Okay, couldn't parse this specific JSON. Why is that? Why is that? Couldn't parse JSON. Okay, you know what? Good opportunity here to use Open Web UI. Okay, so let's vibe code. You know what? Not just Open Web UI. Let me show everyone something cool. So you can actually hook up local LLMs to VS Code with this plugin called Continue. Okay, so Continue, if you install this, it's kind of like a co-pilot for local LLM. So you get to admire and use your local LLM with this specific VS Code plugin. You'll just have to do a little bit of a setup. So in this case, I'll teach you guys how to set that up real quick. So you basically want to hook up to local LLM. So this screen here, you can just choose remain local, and then I think it wants you to do Olama, but I'm not an Olama person, so let's configure it manually. So if you have this here, it's a YAML file. Why is it YAML? I want JSON. How do I do JSON? Whew. Okay, well, let's do it. Let's see. So we don't need any of this, maybe. Well, maybe. Okay, we do. So how do we do this? Is there a URL? You know what? Let's look at the documentation. How do we do this? Continue documentation. It used to be JSON. I swear. It's just changed a lot. So, okay. So let's look at chat model setup. Let's do YAML. So it's going to be provider. We're going to say llama CPP. Model is going to be whatever. I want URL. So how do we get JSON? That's strange. Is there a config.json? There's no config.json? Is there an option? First of all, I don't want to allow anonymous telemetry. Multi-line, I don't even want autocomplete. How do I turn off? Never. Disable, no. Looks okay for now. Yeah, what do we do? Okay, I'll just learn the YAML. There has to be one that allows us to specify some sort of URL. Okay. Here we go, API base. Okay, I think I can navigate here now. Oh, what is this? API base is the key, I think. API base. Models, API base. Models, API base. Okay. Let's copy that. Okay, so it's going to be like this. Models. Name. I'll call this Quen 2.57b. And then provider. Llama.cpp. Model. Quen 2.5. I don't think it matters. API base is going to be HTTP localhost 8888 v1, and let's see if that works. So if I said hi, what ends up happening? Not found. So maybe /chat. Let's see. Hi. No. Why is that? Let's search for llama CPP. Llama CPP. There you go. Llama CPP. Oh, I guess it recognizes it. I don't need a V1. Okay. Hi. Da 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 da. Okay, it works. Yay! We have a AI inside our editor. I don't want Copilot. Let's hide Copilot. How do I bring this to the side? Okay, there we go. Now we're talking. Okay, so let's do some vibe coding for fun. So why would this not be valid JSON? Let's do that. Is this valid JSON? Ugh. It's valid. Oh no. Is it because we don't have choices? Do we? We do. Load S, raw string. Oh, one of these errors. One of these are being raised. That's the reason why. But I thought it would be cool to just show you guys this. So somewhere here it's failing, and I think I know the reason why. It's because content is not in Delta, right? So if content is not in Delta, we can just stop generating. Let's just say that. Or you know what? Let's do this. If choices, okay, we have choices, we have assistant response, we can check for finish reason, okay? So if finish reason, okay, not in assistant response, raise key error, couldn't find finish reason. Okay, now let's check for reason, okay, or finish reason. If assistant response finish reason is stop, we can break. Okay, let's see if that's smooth going forward. That should end beautifully. I'll check back. Okay, it's almost done. So, and this time it should end nicely because now I'm checking for the finish reason. That tells us whether or not we should stop expecting generation. Okay. Looks good. Looks good. We could have just printed out a new line, which I think we should. So I'm going to maybe print this outside of the loop. So somewhere down here. Okay. So that is lined up with the for loop. Just do print. As simple as that. Okay. We don't need any of this anymore, right? Now we have something that can generate tokens repeatedly. Okay, gonna just tuck this away. We can now make this basically a function. So why don't we call this def chat chat chat. Let's call it chat. Okay. Or send message. This is send message, and we can provide a message. Okay, and let's make this encapsulated all the way in here under this thing. Okay, and then we'll have message here. Okay. Now let's turn this into a function that generates the content. So we were printing it before, but we want to return this back. How do we do that? Well, it's just as simple as yield content. So if we did this, basically the caller of this message, the send message, becomes instead of like one result, it's going to be like an iterator of results. So what I mean by that is if I said something like chat or what do we call it again? Send message. Send message, hello there. What's going to be returning back is going to be a generator object, meaning that we had to iterate through the results, okay? And the pattern here is just basically the same thing as like a for loop. So if you just did for token in send message hello there, so what is returned every single iteration is going to be the content that we yield back, and it's only going to exit out of this loop when we break from the generator loop. Okay, so either stop reason or done. I think it's always going to stop here, but just in case. So then we'll just add our print statement here. We'll call this token with the end as nothing, and it will flush immediately so that we can see results immediately. So this is outside the function. Okay, so this def function here is like this def send message function here is one big function that just gonna take in a raw string here and send it off to LLM, and then we're going to stream the responses back in tokens. Okay. And that's through the yield all the way down here. And it's just like a loop. We'll print out each token we received without any separators, and then flush it to std out every single time. So this should still be the same thing. Just have the same effect still. So there we go. Cool. All right. Yeah, I think that's it for now. Yeah, next time we'll do some more things. So let's do this: git add dot, git status, git add dot. Okay. LLM generator example. Okay. Next, I think we should talk about like good resources to learn this stuff. For entertainment, I really like this Reddit subreddit. It's called Local Llama. It's just good to follow like rumors and like just shenanigans regarding the local LLM community and just trying to build some knowledge and stay up to date. It's like cutting edge stuff all the time. So that's one. So Local Llama, I'll put that as a favorite so that we can look at memes and stuff together. And Sam Altman. Another website that I like is, well, not website, what is it? YouTube channels. This guy has been pretty good lately in terms of explaining things. His name is Gary Explains. Yeah, Gary Explains. He explains. He explains lots of things about LLMs. For example, he talks about why GPT 4.1 is better than 4.5, Llama 4. Like he has some of it, but it's not like the best, like the only source that is there to learn. These are just like things that you slowly build up knowledge for. I also recommend like basic deep learning things. I think there was a course, was it Deep Learning AI? What is it called? Yeah, this one. I don't know. It's like I'm not really a fan of like online courses. I tend to like to read and explore on my own, but I've heard some people like this course. But yeah, I mean, really, it's just mostly just exploring and just like being curious and learning how to use some of these tools, which I hope to slowly expose to everyone here what it really means. Oh yeah, no, it just occurred to me. I think your one-stop shop would be Andre Karpathy's, right? Andre Harpathy's channel. I'll subscribe. He has like this 3 hour deep dive to LLMs, and he teaches you basically what LLMs technically are, and it's one of those things where it's like, oh, now you know what goes into the stew, and your stuff does not feel good anymore. He kind of proves that LLMs are kind of like they're dumb, right? They just generate text, and that's all they do. It's not like they know stuff. They're just basically trying to emulate an internet document in this case. So yeah, these are just like basic things to start out with. Very light. So I think it's just more like exploration. Eventually, you'll understand things on your own, or you can just go on this journey with me, and we'll learn together. Cool. That's it for today. Thanks.